Join modern-day aquanauts on their difficult and dangerous journey into the subaquatic world in search of a rare and mysterious shark. Encounter the strange hammerhead, phantom of the deep. Watch divers equipped with high-tech diving apparatus move within mere inches of these creatures that are as feared as they are misunderstood. Explore the underwater wonders of a remote Pacific island, home to some of the largest and most bizarre creatures on Earth. Witness savagery as rarely seen by man, as you are taken into the heart of a natural shark feeding frenzy. Come with us now and join us as we search for the mysterious Golden Hammerhead. Near the coast of South America, where birds soar on cool trade winds that stir the hot equatorial air, lies the Caribbean island of Trinidad. A land of hazy sky, coconut palms, and turbid water, Trinidad's undersea wealth is more than just its offshore oil. Off Trinidad's eastern shore, in the murky, tan waters of Manzanilla Bay, a mysterious golden shark was found that would lead scientists on a long journey to unravel the secrets of its wondrous color. Fishermen from this remote fishing village on the bay have been harvesting from the sea for most of their lives. Existence here is simple, sometimes harsh, with few comforts or luxuries. Visiting shark expert Dr. Jose Castro was surprised to see the rich yellow hammerhead sharks among the fishermen's catch. He soon realized that the sharks were a gold color phase of the small-eye hammerhead, found only in shallow waters from Venezuela south to Uruguay.
I saw my first golden hammerhead in 1985 when I first came to Trinidad to study the sharks here. At first, I thought somebody was playing a trick on me because I had never seen a shark with these splendid colors. Usually sharks are a shade of gray or brown and are usually drab.
Of all the ocean's animals, sharks are the most feared by man. These powerful and mobile creatures are both fascinating and frightening to us because they seem to be so unpredictable, so invulnerable. Yet for all the shark stories and scientific research, we still know so little about them. The scalloped hammerhead is closely related to its smaller cousin, the golden hammerhead. Hammerhead sharks are the most readily identifiable of the ocean's inhabitants. Their unusually wide, flat head gives them an appearance unlike any other elasmobranch. Other sharks have distinctive shapes that provide them with an edge for survival. Whale sharks are the largest fish in the ocean. Harmless to man, these genial leviathans glide gracefully through water like large airships. Its large mouth and efficient gills are ideally designed to capture the vast quantity of food this gentle giant requires each day. The docile shark must constantly sweep plankton-filled waters through its large gills, filtering tons of the microscopic organisms, small fishes, and shrimp for food. Always in motion, whale sharks travel singly or in large schools throughout all the world's tropical oceans. White-tip reef sharks constantly search coral reefs for food. Ever alert for prey, these silent denizens pursue their unending patrols for food with vigor. Their thin, narrow body and lightning-fast reflexes make for a prolific reef hunter. Spotting movement in a hole, a white-tip decides to investigate. Reacting instinctively, the white-tip moves in for the kill, thrusting its narrow head in and dragging the unfortunate grouper out to its doom. No shark strikes greater fear in the hearts of man than the great white. Torpedo-shaped, they are capable of cruising long distances at low speed and launching a high-velocity attack. Enormous jaws filled with teeth are designed to cut and tear its victims, often larger than itself. Angel sharks, often confused for a ray or skate, have flattened bodies that are perfectly designed to hide under the sand, lying in wait to devour unsuspecting prey as they swim past. Shaped like an underwater rocket, the mako shark is the ocean's fastest swimmer. A formidable hunter, its pointed teeth are well adapted for impaling fish and drawing them into its mouth. The tiger shark is the second most deadly shark in the world based upon its attacks on humans. Its ferocity rivaled only by that of the great white. Its teeth and jaws are uniquely designed to saw through shells of sea turtles, its favorite food. The design of the Port Jackson shark includes two rigid spines to render itself unpalatable when bitten by a larger predator, such as the hammerhead, an exceptional hunter who feeds on bony fishes, other sharks, and especially stingrays, its favorite food. Scientists theorize that the shark's unusual head shape provides at least 3 effective tools for hunting. The shark's widespread eyes provide greater peripheral vision so that even the smallest prey can be detected. Ampullae of Lorenzini are organs on a shark's head that detect electric fields of its prey. These organs are more sensitive in the hammerhead because of its broad head. Lacking long pectoral fins to control diving, the shark's flat head compensates, permitting more maneuverability by acting like a diving plane. Working with Dr. Castro, filmmakers John McKenney and Rod Farb sailed to Cocos Island, 300 miles west of Costa Rica, to study hammerheads. The dive vessel, Undersea Hunter, takes anchorage on the lee side of the island. A naturalist's paradise of underwater wonders, Cocos, a Costa Rican national park, is home to many large marine animals that come together in one of the planet's last wild places. Preserving the biological diversity of this unique resource is the primary objective of the Costa Rican government. Over 70 species of birds inhabit the island. Ubiquitous brown boobies nest along ledges overlooking the ocean, while brown noddies make their home in trees growing in crevices along sheer walls. Frigate birds, seldom seen far from land, survey the ocean from high atop steep cliffs that fall away sharply to the ocean below. McKenney and Farb have brought advanced space-age diving equipment, mixed gas rebreathers, to Cocos. In this first-time ever use of bubble-free rebreathers to film marine life here, they intend to meld silently into the undersea environment as they observe animal behavior. Marine animals are often frightened by bubbles from conventional scuba equipment. Sensors that monitor critical oxygen levels in the rebreather must be checked before each dive. Too little or too much oxygen during a dive could prove fatal. Because each breath of air from the system is rebreathed, it contains less oxygen and more carbon dioxide than the previous one. The sensors detecting low oxygen, actually batteries that are powered by oxygen, signal the onboard computer to add more oxygen to the breathing mixture. The buildup of harmful carbon dioxide, or CO2, is removed by its absorption to a chemical scrubber, calcium hydroxide, shown here being packed in the scrubber housing. 8 pounds of scrubber will last 10 hours under normal usage. Divers must be constantly on guard for symptoms of excess CO2 exposure, as there are no carbon dioxide sensors that will work under the demanding conditions of a rebreather. Today's units are highly sophisticated technical diving gear, and as such bear little resemblance to ordinary scuba equipment. Keeping track of 6 gauges and 4 gas valves, as well as 2 hours of daily maintenance, make diving a rebreather more akin to flying an airplane than diving with conventional scuba. These specialized diving systems provide up to 6 hours of breathing time at a fraction of the weight of conventional equipment. Silence and an abundance of air make rebreathers ideal for wildlife filmmakers. Using stealth, the divers are able to approach hammerheads without frightening them away. This silent encounter is a success. The sharks continue swimming undisturbed. Scalloped hammerheads here, gray and drab in color, may provide clues about what the mysterious yellow coloration does for its smaller cousin, the golden hammerhead. Animals become more or less conspicuous because of their external coloration. Approaching noiselessly, divers see the effect of skin color on these animals. Countershading, where the dorsal surface of the hammerhead is darker than its underside, serves to blend the shark with lighter water above it when viewed from below, and with the darker water below it when viewed from above. McKenney and Farb find Cocos ideal because of its diverse marine life. Rebreathers make it possible to film sharks behaving naturally without disturbing their activities. White-tip reef sharks, relentlessly probing the reef in search of prey, take no notice of the silent divers. Eagle rays, normally leery of divers' air bubbles, are easily approached with rebreathers. These graceful animals soar on elegant wings, gliding as light as any wind that blows. Marbled rays are curious companions on every dive at Cocos. The Mobula ray, a close relative of the giant Pacific manta ray, mingles with the vast diversity of marine life here. They are curious about the divers, but approach them with caution. This ray glides effortlessly past the noiseless diver like an alien spaceship propelling through liquid space. The ballet-like grace of friendly bottlenose dolphins swimming with ease, oblivious to current and surge, instill us with a feeling of envy. Green sea turtles, once hunted for their meat, are now protected at Cocos. For reasons known only to the fish, jacks are drawn together in a writhing, synchronous mass of life, a ball of bait fishes that moves through the water as one giant being. A column of fish exceeding 100 feet in height, composed of tens of thousands of jacks, foreshadows formation of the gigantic bait ball. In this rare sequence, we are witness to a natural feeding frenzy. The presence of the bait ball initiates this extraordinary feeding behavior. Massed together, the jacks seek safety in large numbers. Silky shark, dolphin, and tuna charge unremittingly into the large ball of fish. Like swirling leaves in a cyclone, the undulating ball is helpless. Driven to stay together by a force as old as time, survival, the jack's synchronized movements, twisting and darting in unison, seem only to energize its attackers. Seabirds stand by to pick up pieces of fish from the frenetic action. Voracious yellowfin tuna strike at targets on the edge of the ball and devour them without breaking stride. At great personal risk, McKenney and Farb enter the bait ball to film a prey's-eye view of the action. The green jacks are an energized, swirling mass of bodies, creating a dark and disorienting environment in an attempt to confuse their attackers. From below, the bait ball resembles a large swarm of bees being attacked by huge birds. A pod of bottlenose dolphins move in quickly to the ball, adding to the medley of predators gorging themselves upon the hapless jacks. The presence of dolphins momentarily disrupts the ball, sending the bait fishes into panicked flight. The elastic nature of the bait ball is distorted momentarily as the assailants rip into its dynamic core. Almost immediately, the ball returns to its spherical formation. Ranks decimated by the relentless frenzy of feeding, survivors mistakenly seek the protection of the diver's boat. Oblivious to the large, dark object, attacking silky sharks streak to the surface like guided missiles, crashing into the boat with reckless abandon. For John McKenney and Rod Farb, it has been a rare experience to witness this astonishing display of savagery in the wild. The search for the rare and elusive golden hammerhead takes our research crew to Trinidad, where Dr. Castro found the shark 10 years earlier. The team travels to Manzanilla Bay on Trinidad's east coast, where the golden shark is found. Once connected to Venezuela eons ago, the island's plants and animals are more South American than Caribbean in nature. Water surrounding Trinidad is not clear like that found around other Caribbean islands. Though the ocean looks clean and inviting, the surf that washes ashore quickly dispels any notion of tropical paradise. The bay's murky tan color, as well as all of Trinidad's coastal water, is a result of the drainage of Venezuela's vast Orinoco River delta. Fishermen from a single village on Manzanilla Bay do most of the fishing here. Their homes are nothing more than bare shanties, erected among the coconut palms on a narrow spit of land, separating calm water from the turbulent, windswept ocean. "10 years ago, Castro came to this village and discovered the Golden Hammerhead. By allowing him to buy sharks from their normal catches, the local fishermen helped Dr. Castro obtain tissue samples. The hammerhead's rich color renders its skin golden from the tip of its head all the way to its tail. A poor fishing village with little in the way of modern equipment, fishermen here must often struggle to bring in their meager catch. Gill nets have been used for fishing here only since the early 1980s, when the Fisheries Ministry approved their use in Trinidad waters. Early in the morning, a pair of fishermen guide their small boat out through rough surf, heading for the fishing grounds to set their long nets. Once at the site, the net is readied for the day's fishing. Soon they begin the long, arduous process of setting out the half-mile-long gill net. Working as a team, the netman has a difficult job of deploying the net properly, as the boat captain maintains the correct heading across the current. The fishermen must wait nearly 12 hours before retrieving the net in order to maximize the catch of fish for the effort expended. Since it will remain submerged for so long, it is important that the gill net drift properly in the direction of the current. The position of the net is marked with a buoy and a flag so that it may be easily found. Early the next morning, the fishermen return to haul in the net and its catch. The fishermen are lucky today. They have made a good catch, though there are only 2 golden hammerheads among the fish that were caught. Bringing in the net is hard manual labor. There are no electric winches to speed the work. A golden shark can be seen as soon as the net clears the water. It has been a very productive trip, and both men must strain to pull the heavy net and catch to the boat. After a long morning on the water hauling in their net, the fishermen have already sorted their catch before arriving at the village. The golden hammerheads have been separated from the rest, and they will be sold to Castro for his studies. Dr. Castro is surprised that there are so few golden sharks caught during the night, but he gratefully accepts the rare, colorful specimens from the fishermen. The precious sharks are weighed and recorded to compare the catches of golden hammerheads made during previous trips.
These are some of the hammerhead sharks of Trinidad. This one here is the scallop hammerhead. It's actually a newborn of a very large species. They get to be about 10 feet in length, and they form very large schools. This one here is the bonnethead, and it's a common shark of shallow beaches where it feeds on crabs. It's a crab specialist. Here you can see the colors of the golden hammerhead. This is a juvenile. This is almost an adult, but it still has the colors, the bright yellow colors. You can see along the ventral side and the fins and the underside of the head are
quite yellow.
I asked myself, why is this shark yellow? My first guess was that it was pigment. A pigment is a compound that gives color to a plant or animal. For example, flamingos get their pink color from eating shrimp. Now, so in this golden hammerhead, after examining a large number of them, I realized that the small golden hammerheads were eating shrimp. And I wonder, are they getting a pigment from the shrimp? The shrimp, in turn, are getting it from a plant. You know, it's most likely a keratin, which is a type of pigment. So one of the things we're going to do is we're going to open up this golden hammerhead to look at the stomach contents to see what it's eating. Then we'll take the stomach contents to the lab, and we will analyze it to see how this pigment is being passed on through the food chain.
Dr. Castro's earlier examination of golden hammerheads revealed that the shark also ate catfish. He knew Manzanilla Bay fishermen regularly caught golden-colored catfish in the bay. Unlike the hammerhead, the golden color rubs off easily.
So here we have the stomach, and we're going to open it to see what it's been feeding on. You can see it's been feeding on a catfish, one of those catfish with the golden color. This is really gross stuff for this film, but... And here's some shrimp. So as we can see, these golden hammerheads feed on shrimp and on catfish, both of which have that golden pigment.
Fishing is poor this season, so fishermen are able to supply only a few golden hammerheads for Castro's research. Using clean surgical instruments, skin from these sharks is carefully removed by excising small pieces and storing them for further studies in the laboratory. The tissue prepared by Castro will be taken to Clemson University and examined under the microscope by Jennifer Weifels, a PhD graduate student.
What I've got here is skin samples we collected in Trinidad from the golden hammerhead. They're frozen, and we're going to cut very thin sections so we can actually see the pigment under the microscope in the skin.
After the frozen thin sections are cut, they are placed on a microscope slide. The tissue is allowed to gently thaw, binding the tissue section onto the slide. The thin skin sections must be stained with specific dyes to make observation under the microscope easier. Then, the stained tissue sections are examined under high power with a microscope. As Weifels looks at the section, she observes the golden yellow pigment is present throughout the tissue. Biochemist immunologist Dr. Bud Bodine will use his 20 years of laboratory experience to identify the shark's yellow color.
We'll be extracting the pigment from shark fin. I've weighed out 3.7 grams of the shark fin. Notice how orange-yellow it is. Put that into a blender. It's solvent, which is 50 mils of chloroform methanol, containing an antioxidant. The pigment oxidizes, that is, it's destroyed by the oxygen in the air. blender. After blending, the sample is then filtered. Now I'm going to evaporate the extract using a rotary evaporator. This is warmed water here in this. I'm going to apply a vacuum. The solvent will evaporate.
The solvent starts to evaporate as it comes up through the coils, where it is cooled by the ice water and condenses into the flask, leaving the concentrated pigment behind.
The residue here is concentrated now, as you can see. I'll then take this up in a minimum volume of solvent for further work with TLC and higher resolution techniques.
What advantage does the golden hammerhead gain from being yellow? Castro hypothesizes it is camouflage. This would provide young sharks protection from predators during their most vulnerable time. To see if Castro's camouflage theory holds true, the research team enlists the fishermen's help to capture a live shark for the first time ever and film its release. The small fishing boats are loaded with special equipment, including a holding tank for the sharks after they are captured. The villagers gather and watch as the small boats are converted into floating laboratories. The research team heads out expectantly for the first ever attempt at catching a live golden hammerhead and filming it being released. No one has ever tried this before. The fishermen know that hammerheads will not last long when caught on a gill net. The challenge will be to get to the shark shortly after it is caught. Leaving the safety of the village, the scientists know that the trip through these calm waters belie the difficulties in store for them at sea. The plan will be to deploy a gill net in an area known to be frequented by the golden hammerhead. To capture the shark alive, it will be necessary to check the net every few hours. The long gill net is lowered into the sea. The crew work tirelessly setting the net, making certain it hangs properly in the water, much like a curtain. After leaving it set for 4 hours, the fishermen return and begin the long process of retrieving the net and catch. The hard work pays off as the first live golden hammerhead is brought aboard and placed in the holding tank for observation before being released. Today, the shark gets a second lease on life as it will be returned to the ocean instead of landing on a fisherman's cutting block. Meanwhile, back in the laboratory, Dr. Bodine continues analyzing the golden hammerhead skin extract using thin layer chromatography. Carefully adding golden extract to a chromatography plate, Dr. Bodine must wait at least an hour to find out the results.
I'm going to remove the second spot from this plate. We'll then try to recover these off this plate. What I'll attempt to do is to pull this up into the tube. those that are right at the top, near the solvent front.
Chloroform is added to dissolve the pigment away from the chromatography particles. After mixing, the purified pigment goes into solution. To identify the pigment, Dr. Bodine will use high-performance liquid chromatography, or HPLC. While back at sea, the shark is found to be in good health after a brief rest in the holding tank. Working quickly with the shark, McKinney's film crew releases it. In a remarkable achievement, you are seeing the Golden Hammerhead underwater for the first time ever. Even as close as 2 meters away, the golden color of the shark's skin blends perfectly with the surrounding water. Observation of the shark in its natural setting supports Castro's skin color theory of camouflage. Has natural selection produced a low visibility shark that predators would find difficult to see? This would give the young hammerheads an edge on their journey to adulthood. Camouflage would also help conceal the young sharks as they hunt for food. Camouflage is used by marine species for a variety of purposes. Primary among these are avoiding predators and obtaining food. The Pacific Northwest octopus resembles the rock it is sitting on. This flounder, like a chameleon, is able to quickly change its coloration to fade into the background and become invisible. Long and slender grass-like weed whiting blends readily into the seagrass. The decorator crab gathers hydroids to cover itself to become invisible in its surroundings. Dr. Castro's theory is that the yellow color may serve as camouflage for the young sharks. Isolating the pigment responsible for the color would identify the molecular basis of camouflage in the golden hammerhead. Traveling with fresh hammerhead tissue samples, Castro leaves Trinidad to join Dr. Bodine at Clemson University, where Bodine is determining the identity of the golden pigment. A small amount of yellow compound has already been isolated from previous skin samples provided by the Manzanilla Bay fishermen. With this additional tissue, there should be adequate material to produce sufficient quantities of the golden molecule to identify it. Sophisticated analyzers available at Clemson will be used to further characterize the purified material. The purified shark skin extract is readied for analysis by HPLC, a state-of-the-art high-resolution analytical instrument. The sample is injected into the port of the HPLC, where the extract mixture will separate into its individual molecular components. It is at this step that Dr. Bodine expects to finally isolate the pigment responsible for the golden hammerhead's yellow color.
We had this absorbance detector is set for carotenoids at 420 nanometers, just set for carotenoid proteins. And that signal is going to be sent back different peaks, which will show up.
The results of the analysis shows that a major component of the
keratin,
pigment in shark
and some of
skin
its other
is keratin.
metabolites.
To verify this finding, the chemistry department of Clemson University agreed to help the team by analyzing the pigment extract using space-age technology, nuclear magnetic resonance, or NMR. Molecules in a magnetic field behave in a characteristic manner that may be used to identify them. Using NMR, the research team hopes to conclusively identify the yellow pigment.
Okay, what we're looking at is the molar mass spectrum of a fin sample, and what you can see on the screen is the molecular peak at about 650, and then its half peak at about 335.
So it's a keratin like...
Yeah, it's similar in molecular weight to the keratins, yeah.
Well, this is the first confirmation that we have of the field observations that it is a keratin pigment that accounts for the color on the shark. This is the first time we've had actual data to prove the field observations. So the laboratory data confirms our original field observations that the color of the golden hammerhead is due to a keratin pigment.
In Dr. Castro's hypothesis, the golden hammerhead's yellow skin comes from eating shrimp and perhaps catfish that contain the golden pigment acquired from plants they feed on. As the shark eats more and more shrimp, the concentration of pigment increases in the skin, and the richer its golden color becomes.
But as the pigment concentration increases, the colors of the shark become more and more vivid, making it probably one of the most splendid sharks in the world. After the golden hammerhead reaches maturity, the diet changes. It changes from a shrimp diet to a fish diet. And once it starts eating fish, the color starts to fade.
Adults no longer exhibit bright golden color. Though diminished, yellow pigment is still present. This photograph is evidence that the golden hammerheads acquire the yellow pigment from their mother before they are born. Pregnant golden hammerheads carry offspring inside their body until they are fully developed, providing nourishment to the young embryo from a placenta. The pigment responsible for the yellow color of this embryo's skin was passed from the mother through the umbilical cord. Marine animals acquire many things from plants, mostly of nutritional value. The golden hammerhead indirectly acquires a specific chemical, keratin, from plants. Keratin becomes embedded in the shark's skin, producing a rich yellow color. Yellow coloration provides young shark pups with camouflage from predators during a period of life when they need it the most. The golden color is a selective advantage for the hammerhead's survival. Our world is more understandable thanks to the work of scientists like Dr. Jose Castro, who help us to learn how complex animals like hammerhead sharks have evolved successfully. The inhabitants of the world's oceans have taught us that interrelationships among plants and animals on our planet are very complex and necessary for survival. Only by recognizing the existence of these relationships and understanding their nature can we make wiser decisions about human actions that affect our constantly changing environment.